Hello everyone, welcome to Code Crafters Lab. So now we will try to see the optimal approach for checking the perfect number. So we know we are given with n and what we want to return is true if it's a perfect number, otherwise return false. So what is perfect number? It is a number whose proper divisors add up to the number itself, right? So we have solved it using the brute force approach, right, where we were running the loop from 1 to n and we were trying to find the divisor by n modulo I equal to 0, and we were adding the same that ith variable into the sum, right, and at the end we were calculating whether sum is equal to n. That means it's a perfect number, right? So let's try to take one more example and let's understand if we can find some optimal way around it. So it's n equal to 36. So first divisor is 1. Why 1? Because it can divide 36 and 1 into 36 is equal to 36, right? 2 is a perfect divisor, right? Because 2 into 18 36, so 18 is also there. Then 3 is also perfect divisor, so 12. Then 4 is also perfect divisor. 9, then 5, it's not a perfect divisor. Then 6 it is. Then 6 into 6, it is also 36, right? And after that also you can write the divisors, which is nothing but 9, 12, 18, 36, which we already got here, right? We have already here, so no need to write them again, right? So we say here, if we find 1 as a divisor, can we say n by I? So this is I. N by I can be also a divisor. In this case it is 36 divided by 1, which is equal to 36, right? In this case also n by I is nothing but 36 divided by 2 equal to 18. Yes, 18 can be a divisor. Then again 36 divided by 3, which is equal to 12. Yes, 12 can be a divisor. Then 36 divided by 4 equal to 9. 9 can be a divisor. Then 36 divided by 6, n by I equal to 6, so 6 can be a divisor, right? But now the question comes here is why we have to stop till 6. So can we say square root of n can be the condition? So square root of 36 equal to 6, so we have to stop till 6, and then n by I can be your divisors, right? So this can clearly state you have to run a loop till square root of n instead of running the loop from 1 to n. This can save your time complexity also reduces due to this. Yes, we can say that. So let's try to write our code here. Let's say my int sum equal to 0, right? Then I'll write my for loop for I equal to 1 till I is less than equal to square root of n I plus plus. Till now it is same. After that what we did if n modulo I equal to 0, then we were adding the I. We'll do same here. If n modulo I equal to 0, what we will do? We will do sum equal to sum plus I. Again we have to add the n by I also to the sum, right? But there should be one condition around it, right? So here if we see, we have to avoid this and this because 6 is repeated, right? And 36 we don't consider that particular number while adding it to the sum. How we can skip this condition and add only sum equal to sum plus n by I, but we have to add some condition here. If so, can we say if I is not equal to n by I, can we say that if I is 6 and n by I is also 6, so we can avoid 6 n by I, right? And there is one more condition, right? This 36 we want to avoid. So it is n by I is 36 and n is 36. So can we say n is not equal to n by I? Yes, this way if it is true, then only we will add n by I to our sum. And at the end, if we close this both the if, right, and this is for this for loop closure, and we'll do if sum is equal to n, then return true or false. Yes, this can be our solution. And if we'll write one more condition, if n equal to 1, return false. So this way we can avoid it. So let's try to code this here. We will do some changes here. If n equal to 1, what we'll do, we'll return false, right? In sum equal to 0, then I equal to 1, I is less than equal to square root. So we use math dot square root in Java, square root of n I plus plus. Then again this loop will be same, and then this if conditional statement, inside that we have one more condition, if I is not equal to n by I and n is not equal to n by I, right? And if that is the case, then what we'll do, sum equal to sum plus n by I, right? After that I don't see any changes are required. Let's try to run this. Yes, it is passing. And in this case, if we see the time complexity, what is the time complexity in this case? So time complexity can be O of square root of n, because we are running the loop till square root of n, and space complexity will be same, O of 1, because we are using only constant space in this particular example. So yeah, thank you for watching.